everyone, in today's video we're going to be discussing how to apply a sequence of rigid motions. Let's take a look at the first example. A sequence of rigid motions is when two or more transformations are performed on a set of points. Describe a sequence of rigid motions that would prove that triangle ABC is congruent to triangle DEF. So we want to figure out how ABC gets to triangle DEF. I'm going to put 1 and a 2 in to show that I'm starting off with triangle ABC. I need to figure out which types of transformations occur in order to get that triangle onto triangle DEF. So the first thing I see is a rotation of triangle ABC at point C of 90 degrees. And that's going to be a clockwise rotation about point C. So I'm going to draw a quick sketch of what that would look like. So then all I would have to do is translate or slide that triangle over to triangle DEF. So first we did a rotation of 90 degrees clockwise about point C, and then a translation. You could also think of it as the opposite way. You can translate it first and then do a rotation of 90 degrees clockwise about point C. Next, let's discuss what a correspondence is. A correspondence is developed between the figures and their parts. We can list the parts of one figure and pair them with the corresponding parts of the other figure. So, for example, we started with triangle ABC, and we ended up with triangle DEF. So, AB corresponds with DE. They line up perfectly with each other. BC corresponds to EF. And AC corresponds to DF, the first and the third letter. Next, let's look at the angles. Angle A lines up with angle D. Angle B corresponds to angle E. And angle C corresponds to angle F. When each side and each angle on the pre-image maps onto corresponding side or angle of the image, the two triangles are said to be congruent. So remember, I start off with triangle ABC, that's my pre-image, and after transformations occur, I end up getting triangle DEF, which is my image. Let's take a look at an example. In the following diagram, triangle BAT is congruent to triangle ICE. In the box below, identify the corresponding angles and corresponding sides. So I'm going to write and line up my letters BAT and ICE. Let's first do the angles. So angle B corresponds to angle I. They're right underneath each other. So angle B is congruent to angle I. Notice that there's one congruence mark for that angle in those two angles. Angle A is congruent to angle C. They correspond to each other, and there are two arcs in A and C. Finally, angle T is congruent to angle E. They correspond to each other, and there are three arcs showing congruence. Next, let's take a look at the corresponding sides. So we have BA corresponds to IC. Therefore, BA is congruent to IC. Notice there's one congruence mark. AT is congruent to CE. there are 2 congruence marks. And finally, BT, the first and the last letter, correspond to IE. They have 3 congruence marks. Let's take a look at 2 examples. If triangle JKL is congruent to triangle MNO, which statement is always true? So once again, I'm going to line up the letters JKL, MNO. Which statement is always true? Now let's take a look and see which sides or which angles correspond for each other. So pause the video now to try. If we notice, it is answer choice 3 because JL, which is the first and the last letter, is congruent to MO, the first and the last letter of the second triangle. Let's take a look at number 3. In triangle MNP congruent to triangle VWX, and PM is the shortest side of triangle MNP, what is the shortest side of triangle VWX? So once again, I'm going to line up the letters. So MNP, VWX. So PM is the shortest side. So here's P and here's M. What's the shortest side of triangle VWX? So P corresponds with X and V corresponds with M. So XV has to be the answer. Let's take a look at number 4. Describe a sequence of transformations that will map triangle ABC onto triangle DEF, as shown below. So remember, when it says a sequence of transformation, that has to be more than one. So I have to get triangle ABC, which is my pre-image, which I'm going to put a number 1, and get it onto triangle DEF, which is my image, so I'm going to put a number 2. I'm going to line up my letters A, B, C, and D, E, F. So I notice right away that ABC is going clockwise and DEF is going counterclockwise. So I know that the orientation has changed, so it must be a reflection. So for me, I believe it's going to be reflected over the x-axis. So let's count some boxes. So there's 3 boxes here. There's going to be another 3 on the other side. We'll call that A prime. B is 3 on the other side as well. We'll call that B prime. And C is 1, 2, 3, 4, 5, 6 boxes away from the line. So we'll go another 6 on the other side. 1, 2, 3, 4, 5, 6. So right now we did a reflection in the x-axis. Again, make sure you're specific. Don't just say reflection. You have to say where. Next, remember that A and D correspond to each other. So how am I going to get A prime onto D? Well, that looks like a translation of 1, 2, 3, 4, 5, 6 to the right. And again, you could check this by C has to go on to F, so you can count 1, 2, 3, 4, 5, 6 to the right as well. Now, you could have also done it opposite. You could have first said that there's a translation 6 units to the right and then a reflection over the x-axis. Both answers are correct. Let's take a look at number 5. Quadrilaterals BIKE, bike, and GOLF, golf, are graphed in the set of axes below. Describe a sequence of transformation that maps quadrilateral bike onto quadrilateral golf. So again, it says a sequence of transformations, so I know it has to be more than one. So the first thing I want to do is line up the letters bike and golf, so I know which letters correspond. So I'm going to look at bike to see what direction those letters go in. that's going to be counterclockwise, and golf, it's going to be clockwise. So I know right away that it has to be a reflection of some type. So I'm going to reflect it over the y-axis. So I reflected bike over the y-axis, and I got B prime, I prime, K prime, E prime. So let's write that down. Reflection over y-axis. And again, make sure you're specific. Then it looks like it's a translation where I slide up. So notice E and F correspond to each other, so let's count the boxes. 1, 2, 3, 4, 5. So that then it looks like a translation of 5 units up. And again, you could check that with all the other points and their corresponding point. 1, 2, 3, 4, 5. So we have a reflection over the y-axis, then a translation of 5 units up. We can rewrite it as a little r, which represents reflection, then a translation of 0 units to the left or right, and 5 units up.